Okay, so section 6.3 actually involves adding and subtracting uh, algebraic expressions. But before we go there, we need to remember how to find least common denominators, which the concept of least common multiple is going to tie in here. So I want to find the least common multiple of 28x to the 8th y to the 6th and 4x to the 9th y to the 7th. Now, students get this mixed up a lot of times. They think I'm asking for greatest common factor, which I'm not. I'm asking for the least common multiple, the smallest thing that they both have in common as multiples. So here's how I like to teach this. Let's look at the numbers first. 28 and 4. If I start listing the multiples of 28, that would be 28, 56, and so on. You can see they're getting bigger. Okay, you keep adding 28 each time. All right, now if I start listing the multiples of 4, I have 4, 8, 12, 16, 20, 24, and 28. Bingo, let's stop there. The number 28 is the smallest number in both lists. So that means they both have 28 in common as a multiple, and it is the least common multiple. So we know 28 is the number that works. Okay, if I look at x to the 8th and x to the 9th. Doggies, hush, Daddy's filming. Sorry. Doggies, Paduti. Zeus, button it, dude. Okay, let's look at the x's. X to the 8th, my multiples would be x to the 8th, the next one would be x to the 9th, x to the 10th, and so on. Okay? My multiples of x to the 9th would be x to the 9th, x to the 10th, and so on. Okay? Which is the smallest thing that matches in both lists? That would be x to the 9th. So, x to the 9th goes next to the 28. And how about y to the 6th and y to the 7th? Well, come on down here. The multiples of y to the 6th would be y to the 6th, y to the 7th, y to the 8th, and so on. The multiples of y to the 7th would start with y to the 7th, the next one would be y to the 8th, y to the 9th, and so on. What number do you see that's common to both lists that's the smallest? That would be y to the 7th. Okay, so my final answer here would be 28, x to the 9th, y to the 7th. And here's a very easy way to do it with exponents. We have an 8 on the x here, we have a 9 on the x here, it's got to be a 9. It's got to be the larger of the two for it to be in common. And y to the 6th, y to the 7th, which is the larger of the two, the 7. The numbers are more of a pain, okay? And you can actually do the numbers with prime factorizations also, but I personally prefer to show people this method of making lists of multiples and finding the smallest one and pray that these numbers aren't ridiculously large. Okay? All right, one last problem here for this first video. Add or subtract as indicated, and then give the final answer in lowest terms. One thing I want to remind you about, this is not something that you're solving, this just says add these together. Why is this an easy problem? Well, whenever the denominators are the same, it's an easy problem to add. You put the same denominator one time and you add the numerators. 7 plus 2 to give me a 9. So we're starting off very simple. my answer to that addition problem would be 9 over k. Now, part of what makes this problem so easy, the denominators were already the same. And what you need to remember from arithmetic, when you're adding or subtracting fractions, you need identical denominators. Think about this. If you were adding quarts to quarts, you're in good shape. If you were adding quarts to gallons, you couldn't just add them until you converted one to the other. So an easy arithmetic problem is a problem where the denominators already start off the same. You put it one time and you add the numerators, or you do whatever it tells you to do to the numerators. Okay? And we're going to look at some more examples, but this is just getting us going.